All right. So first of all, what is FreeBSD? I almost felt bad advertising this, I guess, presentation here because I feel like when I say FreeBSD, most people have no clue what that is in their mind. They may have like some semblance of what Linux is, right? It's what's found on those CSE lab machines that you use when you SSH for 2021, 2041, or 44. 2041, 4061, etc. But FreeBSD is an operating system just like Windows or Linux, like you'd find on those CSE lab machines. Technically, what I just said there is wrong about Linux because it's actually GNU plus Linux. Most people simplify it, right, to just Linux, but this is a very important topic here, a very important distinction because FreeBSD is an entire operating system, right? Whereas most Linux systems, when you refer to them, you're actually referring to the GNU set of utils and the Linux kernel, right? So if you have no idea what I'm talking about, we're going to get into that, so don't worry about it. But basically, FreeBSD, just another operating system, something that you can install on your own computer and use it as a replacement for like Mac OS or Windows or GNU plus Linux. So that means that FreeBSD is composed of user space and kernel. If you've taken 4061 at this point, you'll have somewhat of an idea of what the distinction is between these two things. But user space are generally, this term's a little bit ambiguous at times, but are generally referred to the utilities that run on top of your kernel, right, to allow easy access or easy interfacing with the lower level components of your system. So that includes text processing programs like grep, awk, and v, if you've ever used that, or vi. User shell or interface, so that Windows start menu that you press on, that's part of user space. Or when you go to the Mac OS dock, right, that's all user space stuff. And on top of that, there are graphical applications that are part of user space. For example, when you open Google Chrome or you open Mozilla Firefox, all of that is happening in the user space. So then you might be thinking, well, what the heck is the kernel then? You basically just described what my computer is. Well, the kernel is the other side, the side that you don't see, or really what I like to think of is the side that does all the heavy lifting in terms of really low hardware support. That means that kernel is the bridge between the hardware and the software. So if you open up Mozilla Firefox and you're joining a web meeting, right, say you're joining a Zoom call, and you want to enable your webcam, well, Google Chrome doesn't have the code in it to directly interface and grab those ones and zeros from the webcam and translate it directly to a video feed. Instead, the kernel gives some abstractions in order for your web browser to easily just say, hey, I want to use the webcam, and then it will receive a video feed from whatever webcam driver that your kernel provides. When you hear the term driver, that's more commonly used on Windows, I believe, that is most likely referring to a part of the kernel or a piece of software that allows you to connect a hard piece of hardware and allow functionality on an upper level program like Google Chrome or Mozilla Firefox. When you open Finder or I believe File Explorer in Windows, the reason it knows where those files are and how to get those files and access those things is because the kernel gives it a list of those different files that are found on your block device or your SSD or hard drive, right? So basically the kernel is in charge of feeding those lower level hardware devices into your upper level programs. And on top of that, this is a more popular one, graphics cards. If you've ever launched a game to start playing, it's probable that you have an external graphics card in your system. And there are vendors like Intel, NVIDIA, and AMD that provide drivers, be it open source or not, to interact with your hardware, right? So your actual graphics card can do those computations efficiently and feed it into the game. So what I'm really getting at here is game rendering and the fast FPS that you get when you're playing games wouldn't be possible without a kernel or a graphics driver accelerating that information going into the game. And of course there are abstraction upon abstraction upon abstraction in this kind of stuff, but really the kernel is the lowest level part of that. It basically just allows you to access the hardware. One of the biggest responsibilities of the kernel is to manage processes, file systems, communications, and system startup. So without a kernel, you wouldn't even be able to boot your system. It's an incredibly important part. And like I've said several times at this point, it is the nearest to the machine component of the FreeBSD stack. And I shouldn't just say FreeBSD stack, it's just in general the lowest component of your software that you're using. It's almost guaranteed that you're going to have a kernel or some kernel-like system at the very bottom of the operating system that is running on your computer. So why exactly should I care? Moving all of that introduction stuff aside. Well, I mentioned a lot of this in my advertisement for this talk, but FreeBSD is predominantly found in Apple's iOS, iPadOS, and macOS. So if you happen to have a Mac or an iPhone, you can actually go to the header files, and this also works on iOS, but we just can't access them. But you can go to the header files, and let's see, there we go, can make it bigger. So if I ls here, right, this disgustingly long path to get to the header files for macOS, which would usually be a user include for like a Linux or a FreeBSD system. You can go to this, list the files, and then for example, if I want to say, what's a good, event.h, right? This is a header file. You can go to the bottom here, and right in macOS, you can see like the FreeBSD tag. And this is a recurring theme throughout most of these files, right? You can go into them, see, oh, FreeBSD worked on this, FreeBSD contributed to this, and really the only thing that Apple needs to do in order to provide back to FreeBSD is include that license that's right here, we'll get into this later, the 2-clause BSD license in their software that they redistribute. Okay, so back to the why should I care. If you don't care about Apple products, that's understandable. The foundation for Sony's PlayStation, so if you're a big gamer, specifically a Sony gamer, you probably used FreeBSD at some point. You can go through FreeBSD and the Nintendo Switch open source licenses page, because I think by law they're required to publish like what open source software they use in their systems. You can find FreeBSD's copyright notice, that same one that I just showed you in that header file. You can find that inside of PlayStation and the Nintendo Switch OSs, which I think is kind of neat. So really, you wouldn't have an OS to play your games without FreeBSD. Netflix is another big popular one. If you've ever streamed Netflix at all, chances that you've used FreeBSD or at least been served content by FreeBSD is almost 100%. And that's because Netflix's operating system of choice for sending out video is FreeBSD. So that means most of their systems will use a FreeBSD operating system underneath. And as a result, I think this is a pretty insane statistic. FreeBSD was responsible for delivering 32% of all internet traffic in North America. I don't exactly know the date in which this statistic came from, but I found it on the FreeBSD handbook, which we'll talk about in a little bit. It's also the backbone of WhatsApp Messenger. The guy who created WhatsApp Messenger is a really big fan of the operating system. He donates millions a year to the project. So he really likes it, and he uses it for WhatsApp servers. And then Juniper is one of those companies that you don't hear a lot about, but they're one of the biggest players in like cloud computing and networking and allowing all of your computers or all of your internet traffic to get from one computer to the next, right? In order for that to happen, you need switches and other relays for that information to flow through. Juniper, and specifically JuneOS, which is based on top of FreeBSD, is primarily responsible for guiding a bulk of internet traffic in the US. So a lot of your internet traffic goes through FreeBSD systems. So a little history before we get into why I think FreeBSD is a great operating system. This may be a little bit boring, but I think it's incredibly important just for any computer scientist at all. This is stuff that you should probably know about. The inception of the Unix system by Dennis Ritchie and Ken Thompson started in 1969. And you hear that term thrown around all the time, Unix system, right? That's just an operating system that was created in 1969 by AT&T, or specifically Bell Labs, which was a sub-company of AT&T. And it was specifically created by Ritchie and Thompson. And Unix was especially important at the time because it was an operating system that was, number one, written in C as opposed to assembly, meaning that when you write things in C, hopefully you know at this point that you can take C code and you can compile it down to the machine code, like assembly instructions, and then down to the ones and zeros that run on your actual machine. You can do that with varying architectures. So if you have a, say, Mac that runs an Arch64 or AMD, or not AMD, Arch64 or ARM chip on it, then you can take C code that was written on that ARM computer and then move it to an AMD 64-bit computer and compile that C program, and then C will do the job of converting that program into the specific ones and zeros or machine instructions for that platform. So this was incredibly important for distribution at the time because computer acceleration was fast, right? New architectures were coming out left and right. It was a time of big growth with computers. So naturally, when something came out in C that was able to be migrated to different platforms with very little work, it became a predominant system to be used and I guess extended in compared to other operating systems at the time like Multics. Next, we have the formation of the Computer Systems Research Group. So this was in 1974, and the Computer Systems Research Group was formed by a few people at the University of California, Berkeley, and they are the primary organization or group that is responsible for governing BSD. When I say BSD, that actually is an acronym for Berkeley Software Distribution. It's not entirely important for knowing about the OS, but that's where its origins come from, Berkeley. So Computer Systems Research Group formed to create BSD. In 1976, Unix v6 finally became widely available to the public, right? So if you remember, I talked about how it was written in C. Well, Unix v6 was the first operating system that was distributed open source to other universities, right? So if you were a university at the time in 1976, you could go to AT&T or Bell Labs and ask, hey, I want your source code for Unix. I want to do something with it. I want to expand upon it. And they would give you the source code to work on, right? Okay, so after that, we have the Berkeley Networking Release 1. Berkeley Networking Release 1 was not really an operating system in entirety, but more so just a set of utilities that allowed for easy networking with the DARPA protocol. So if you've heard of TCP/IP at this point, this was the first widespread C code release that allowed you to interface with TCP/IP. This means that back in 1989, if you wanted to interface with the general internet, right, you needed to have this set of patches in order to successfully or easily interface with the rest of the internet. Okay, so after that, there was Berkeley Networking Release 2, and the names here are kind of confusing, but Berkeley Networking Release 2 was actually the majority of an operating system. So whereas Release 1 was a set of networking utilities, Release 2 was almost a complete operating system minus like a few extra files. And people could buy both of these networking releases for like, I think it was $1,000. And really, once you bought it, then you could just distribute it to other people. That was completely legal. So only one person needed to buy it, and you could share it with everyone. And then you might see the Linux after there. This is when the Linux you all know came out, and Linus Torvalds released, I believe it was version 0.0.2 at the time. And he said it was just a hobby project. And a year after that, Bill Jolitz released 386 BSD. And 386 BSD basically expanded upon Berkeley Networking Release 2. If you remember, I just said that Berkeley Networking Release 2 was missing a few files to make it a complete operating system. Well, 386 BSD took that, right, Networking Release 2, and then added a few extra files into it to make it an easily accessible and bootable system. Meaning that you could just take 386 BSD, it was distributed for free, and then use it for your own leisure, right? It was easy to install, and it was comparable to what AT&T was offering with Unix at the time. This brings us to the big debacle. Unix Systems Laboratories versus BSDR, or Berkeley Software Distribution Incorporated. This massive lawsuit, it lasted for way too long, but it basically trapped all BSD development for as long as the lawsuit was going on. I think it was like 5 years or so. And because it was halted, Linux caught up. Linux caught the wind, and it grew above BSD. And the reason the lawsuit was happening was because Unix System Laboratories saw that BSD was catching on at the time. And they realized, hey, this is something that people actually want to use. They want a freely distributable operating system. Well, BSD technically derived a lot of its code from our stuff, right? BSD is Unix-like, or some people would say Unix-based at the time because it included files from Unix. So they said, hey, you have proprietary software or proprietary code in your system. That's not legal. That's breaking our license. So we're going to sue you. And that went on, and it was an extremely petty lawsuit for a while. But amidst the lawsuit, NetBSD and FreeBSD, what this talk is about, spawned out of 386 BSD. Bill Jolitz at the time did not have the resources in order to keep developing his operating system. So NetBSD and FreeBSD took out Bill Jolitz's code and then expanded upon it. And then finally in 1995, we have 4.4 BSD Lite Release 2. Long name, but this was the first completely open source and completely free version of BSD. Meaning that Computer Systems Research Group that was in charge of distributing it, along with BSDI, did not charge for this release, meaning that anyone could take it directly from the source and use it. CSRG also disbanded at this time as a result of the lawsuit. This was when it ended, I believe. And at the end of 1995, OpenBSD spawned, and OpenBSD was basically just a fork of NetBSD at the time. The distinctions between those different BSDs aren't necessarily important. FreeBSD is just, it puts a focus on ease of use, whereas the other ones put a focus on cleanliness of code. So that's why FreeBSD is the more popular one by market share, just because it's easier to use. At least that's my impression of it. I put this quote at the bottom here because I thought it was interesting. Linus Torvalds in Meta Magazine in 1993 stated, if 386 BSD had not been available when I started on Linux, or had been available when I started on Linux, Linux probably would not have happened. So that just, I feel like, goes to say that BSD caught that lawsuit at the worst time possible, and really BSD could be what we're running on the CSC lab machines today. But instead, because of that lawsuit, Linux took its place and then rose in popularity. All right, so with the history out of the way, why should I use FreeBSD? So FreeBSD is a great operating system to learn more about operating systems. I wouldn't necessarily recommend your grandmother install FreeBSD on her computer. It's certainly not that easy to use. But if you're interested in kernel development, then FreeBSD is a great resource. So the first reason why I think this is because the FreeBSD handbook is an absolutely amazing resource. If you think about Linux distributions, there are so many of them out there, right? There's Arch, there's Debian, there's RHEL-based distributions, there's Slackware, and I could go on endlessly, right? There's so many different distributions out there, and the crappy thing I think about all these distributions is that they each have a different way to handle things, right? They each have a different sound system by default. They all have a different init system by default. This is becoming more universal, right? As time goes on, distributions are sharing components, but there's still that variability that you get when you're using one Linux distribution versus the other. What the FreeBSD handbook does is it serves as an all-purpose guide for just FreeBSD, right? There's no FreeBSD distributions. FreeBSD exists alone, and the handbook is a great way to learn about exactly what you can do for FreeBSD. So if you're running into a problem, you look it up in the handbook. They have a search mechanism, and chances are if it's documented, you can find the solution to that problem without tinkering too much. Another thing is man pages. This is especially useful if you do kernel development or low-level systems development. FreeBSD just has generally the best worded man pages in existence, in my opinion. Compare this to Linux's man pages, which are just, I feel like they're an afterthought by most developers. They write their software and they're like, crap, I need to include a man page with my software. Well, FreeBSD treats those equally, right? The development is just as important as the documentation, meaning that when you want to use a utility, it's going to have great documentation accompanying it. So what I have here is the FreeBSD number of handbooks, right? There's the developer's handbook, the architecture handbook, the regular FreeBSD, this is for users, their handbook, and then the porter's handbook, and we'll get into ports a little bit later. Okay, and also man pages, right? FreeBSD has an online man page search. So, for example, if I want to search ls, right, this will give a description of what ls does with all of its flags. And I find, again, these man pages to be well described, right? If you're trying to really understand how an implementation works, then you go to the FreeBSD man pages. Okay, so next we have the ZFS file system, or the zettabyte file system. It's fundamentally different than most other file systems because it is the volume manager and the file manager, meaning that it understands the notion that you have multiple disks. Whereas a normal file system, say like ext4 on Linux, can only be put on one disk, ZFS can span across multiple disks. This is especially useful, you can imagine, in server environments where you have massive pools of data, right? And those pools of data all need to be combined together, or to simplify things, can be combined together to make a more simplified experience. It also has copy on write design by default, which almost, I like to describe this as if you're taking a snapshot of your system. Say, right, you copy everything in your system over to a snapshot. That snapshot will only take the size of the pointers from the previous or the current system, right? Instead of copying every file byte for byte, you're copying pointers to the previous objects in that system. If I'm not really describing this as well as I think it should be. If you're interested in copy on write, I think it's a really interesting concept, and you should definitely give it research. But where this all goes is FreeBSD is a first-class citizen for ZFS support. So if you're interested in doing large server-scale projects, consider using ZFS because it gets #1 priority on FreeBSD. Okay, so next we have jails, and jails are one of the most, I think, touted features of BSD. If you've ever heard an old BSD guy talk about FreeBSD or NetBSD or OpenBSD, they'll talk about jails. And jails are really just another virtualization method. Kinda, you can think of them like Docker or Kubernetes, right? Where jails differ is they're a lot more simple and a lot less security focused. Not that Docker is secure. Their simplicity makes them extremely high performance and low resource usage. And they're built on top of change root or chroot. And they just virtualize access to the file system, the users, the networking subsystem, so that the isolated environment kind of feels like from the inside that it's its own operating system. So in order to create a jail on FreeBSD, this would almost be like creating a virtual machine image on any other operating system. You just do BSD install jail and then the location of where you want to install the jail. And then that will automatically fetch all of the FreeBSD components and put them into that directory. So then when you start the jail down at the very bottom, it knows, okay, we're an isolated operating system. We're kind of like a virtual machine. We're going to start isolated, and then based on these settings, you can get into that jail and you can treat it like a virtual machine. This is especially nice because when you're using jails, you can do development on them. You can install different versions of libraries. If you don't want to clutter your system with a certain utility, you can put it in a jail. If you're worried about a utility compromising your system, you can put in a jail. I wouldn't necessarily recommend that because jails aren't really secure, but they're just a way to isolate another version of your operating system. So for example, if I were on FreeBSD 14, which is the latest bleeding edge version, I could make a jail of FreeBSD 11 and then have access to all of the FreeBSD 11 resources inside of that jail, all of the stability that comes associated with FreeBSD 11. So it's really like containerizing another operating system or creating a virtual machine that's extremely lightweight. And as you can see here by this slide, jails are extremely simple to set up. This is all you need to set up a jail, as opposed to, I feel like virtual machines are easy to set up now, but that's because they have an interface in front of them and generally a hypervisor that the operating system interfaces with. But jails, they're just this one configuration option in etcjail.com. And you can add multiple here, starting with the jail name. So the jail name here is www. You can add a host name, an address, and then what you want the start command to be. So RC will start the init system. And then when you want to stop, it will stop the init system. But generally, jails are just a very useful utility to know when you're developing on FreeBSD because, for example, I use them for Node.js development. When I want to put a Node.js server inside of FreeBSD, I just create a jail for it, put Node in there, never think about it again. Right? It's not really on my primary system. Instead, it's running on a jail. All right, standardization is a really big one. If you've ever used Linux, then you'll know that, well, not if you've ever used Linux, but if you've ever used it extensively, then you'll know that there are many different sound systems on Linux. There's ALSA, there's Pulse Audio, there's Pipewire, there's Port Audio, I believe. All of these are, I feel like they describe the Linux experience. It's all fragmented because Linux is an operating system of choice. I'm saying that kind of like as a way that you can attack me, say like, oh, well, FreeBSD isn't though. Well, you can still install all of those utilities, but the nice thing about FreeBSD is that it gives you a good set of very sane, very stable defaults to use. You don't need to think about choosing something. I often find myself being happier when I'm given less choices, right? When I install Arch, for example, I can choose if I want systemd boot, I can choose if I want grub, I can choose if I want lilo, right? I don't need to do all of this on FreeBSD. FreeBSD comes with one init system that works perfectly, it's extensible with Lua, and it's great. So bootloader is a big thing for me. I really like the idea that I never need to think about my bootloader. ZFS, we talked about a little bit before, but ZFS integrates directly with the bootloader, meaning that you can take those snapshots that I described earlier, and you can boot directly into a snapshot based on just a configuration or like a key press in the bootloader. So for example, if my system has a stability problem in the latest kernel update, I can just restart my computer, go to the bootloader, say, hey, I don't want to boot with the latest version. I want to boot into this snapshot, and then I can just boot right in. It's integrated right into the system, no setup required. Additionally, there's boot environments. So this is kind of like the reverse of what I was just talking about. If you have, say, for example, a FreeBSD source code that you want to compile, you use a boot environment script. It's called BECTL. You run that script, and then it will compile that FreeBSD source code into a new bootable image. So next time that you boot, you can choose in the bootloader, hey, I want to boot into that image that I just created with BECTL. And then if that image doesn't work, for example, then I can just move back to my previous version. Next is package. So this is another really big problem for Linux, in my opinion. DNF, apt, pacman, whatever Slackware uses. All of those are different package managers that you need to know if you're going to use various different Linux systems. And the problem with all of those different Linux or package managers is that they require different ways to package your applications. FreeBSD, their packaging is extremely straightforward through the use of the ports tree. The ports tree is just a Git repository that you can clone. You add a few instructions in a make file with the included version and like a link to fetch the project. And you add that to the repository in the section that you want the application to be contained in. And then on the next iteration of FreeBSD's build that they run themselves, your application will be built by their systems. So that means as long as you get it committed to the ports, there's no extra work to be done. And this eliminates the need to package for DNF or package for RPM and package for Deb and package for Pacman, right? You just have one system to package for. Poudriere is another thing. So when you're making your ports, say you make your make file inside the ports tree, and then you say, hey, I want to run this make file and make sure that my application that I'm trying to port to FreeBSD runs successfully. You can run a command called poudriere, and then that will use jails to create a jail, completely fresh FreeBSD system, and then it will install all of the necessary libraries that you state in your make file, and then it will run a few tests on that application to make sure that it successfully builds, it successfully runs, it successfully links with a completely fresh system. All right, and then finally, we have ktrace and kdump, which are both user space utilities that are part of FreeBSD. I included these because I feel like debugging the kernel on Linux is a lot less straightforward than it is on FreeBSD. Again, because FreeBSD is an operating system and a user space, it's made by the same people, so the same people can, you know, the kernel people can go into the user space and add stuff that they think should be there. Whereas Linus Torvalds is very against the collaboration of user space and kernel space. So this means that utilities like ktrace and kdump are made by the kernel people, and they're made to debug the kernel, right? So you get a very seamless kernel debugging experience when you use ktrace. You can just use ktrace and then the name of the application that you want to debug. it will gather all of the system calls that were made. It's kind of like systrace on Linux. And then you can use kdump to decode that message. And I've never had a problem with this. It's worked flawlessly every single time I want to debug a problem. All right, so next is operating system cohesion. So since FreeBSD is an operating system, again, kernel and user space, it can use ktrace and kdump. And like I was talking about before, ktrace and kdump are made by the same people that the kernel does. That's basically this slide. Okay, so simplicity, right? A lot of you have probably heard of the systemd debate, right? A few years ago, or it's probably around a decade ago at this point, Linux systems started switching to a new initialization system or init system called systemd, which has been very controversial because systemd is incredibly complex compared to the old Linux init system. It is, in my opinion, a good init system. It does its job the majority of the time when I try to use it. But when something breaks, it really breaks and it goes bad. And files are spread out everywhere by systemd. If you want to start something at boot, you need to add a service file. And you might have multiple service files in multiple different locations for multiple different things. And it quickly becomes a rat's nest of different files everywhere. FreeBSD's init and service configuration is pretty much dead simple. You can see this as a bad thing or a good thing, but I like its simplicity. So what's nice about FreeBSD is everything is basically kept in rc.conf. You can expand rc.conf into different files, like you could include another C or another header file, but I just like to put everything in one rc.conf file for easy migration, right? I just push this to my GitHub repository or Git repository, and next time I want to start a new FreeBSD system fresh, I just move this into etc rc.conf, and then my new system is pretty much right where I left it off. You can see different options here. So for example, how you configure the networking, that would be the WLAN stuff. How you configure your graphics drivers, that'd be the DRM stuff, webcam, dbus, all that stuff. Whenever you want to start a service, you can just put it in rc.conf. There's no obfuscation from you. Everything's pretty much, like I said, dead simple. It's right in front of you. And like I was saying, that makes it extremely easy to just copy this one file, move it to a new system, and have a FreeBSD system up and running that was just like your old one. Licensing. I said I was going to talk about this earlier, and this is one of the, I think, largest motivations for using FreeBSD for a lot of people. FreeBSD is specifically using the 2-clause BSD license, or it's sometimes referred to as the FreeBSD license because it's the biggest project that uses it, I believe. But the gist is, do whatever you want with my code. Just don't remove my copyright notice, right? If you remember those header files that I looked at on macOS, that they still had the copyright notice in them, but you can't sue me if it breaks, right? So if you use the BSD license, pretty much anyone can use your code and incorporate it into proprietary software. And that differs from licenses like GNU, or the GPL, GNU GPL. And GNU GPL stops you from using that kind of software in proprietary applications. So here's an example of what the 2-clause BSD license looks like. You have your copyright, your year, and then your name as the copyright holder. You have your 2 clauses, and there are, I believe, 3 and 1 clause BSD variants, but 2 clause is the most popular by far from what I've seen. And this is basically saying what I said on the last slide, those 3 points. Do whatever you want, just include copyright notice, just don't sue me. All right, and then finally here we get to the community and contribution. So the FreeBSD community is an extremely tight-knit and dedicated community. If you try to develop for Linux, you might struggle to get in with the kernel developers. It's hard to submit a patch to the mailing list and be accepted and build up a reputation in the Linux community because it is so large. And also, because of how big it is, it's hard to find where to start. Again, the FreeBSD has the handbook, and the developer's handbook is the perfect place to look. Hey, I want to get started with FreeBSD development. Go ahead, take a look at the FreeBSD handbook, and it includes steps on where you can start, what needs contributing, and it will guide you through working with an operating system as opposed to the Linux documentation, which I often find just horrible. It's hard to find anything that is user-friendly in that documentation. Another thing is mailing lists. If you're part of the kernel group that has recently formed, you'd know that the kernel community in general uses mailing lists to communicate. This may seem archaic to a lot of you, but email is easy and pretty much everyone has it. It's an old protocol, and if it isn't broken, don't fix it, right? So that's their philosophy. They still use email, and a lot of discussion happens on the FreeBSD mailing list. The FreeBSD mailing list can be found in Appendix C of the FreeBSD handbook, and that's how I got involved. It was funny, I just sent an email to the FreeBSD, one of the mailing lists, and I got a response from one of the head administrators at the FreeBSD Foundation, and he said, hey, we have some work to do here. Would you like to help? And I got involved in porting a file system called lindebugfs. All right, so that brings me, we have around like 12 minutes left. That brings me to a FreeBSD installation demo. So I'll show you how easy it is to get started with FreeBSD. So really all you need here is, let's see if I can find it, a USB drive, right? And this USB drive just needs to have an ISO or an image burned onto it that includes FreeBSD, and you can get that from freebsd.org, right? Download FreeBSD, and then you can choose your release. I'd recommend 13.1. So like, for example, AMD 64, and then you just choose the one that you want. If you want an ISO, the disk or DVD, and memstick if you have a flash drive, right? So I just took that memstick image here. Ooh, I don't want to download it. And I burned it onto this USB drive. So when I stick it into here, hopefully, I didn't test this, so hopefully this works. Let's see, is it on? Hopefully, this will boot into. Oh, I didn't put the PS2 port in. Old PS2 port.
Make sure you're plugging into the purple one.
The purple one?
Yeah, purple is for keyboard, green is for mouse.
Okay.
I don't know how to remember that.
All right. All right, so you'd want to go to your boot menu, and then you'd see this. This is the bootloader that I was talking about before. Let's see. And normally you'd just press enter, and then that would boot your multi-user mode and go into installation. But this is where you'd see like options, and then see, for example, here I could just press 6, and then that's where I cycle through those ZFS boot environments that I was talking about before. But let's just boot. And then that will go through all this crazy stuff. It may seem like a lot, right? Like hacker stuff, but it's nice because it's easy to debug. If something goes wrong, it will tell you, unlike a lot of other systems. So that puts you right here. And of course, you're going to want to install, continue with the default key map. Let's just set FreeBSD. And then this is where you choose. Yeah, sorry, the PC is really loud, so I apologize if you can't hear me.
He's old and tired. Give him a break.
So this is where you can choose your what you want included with your FreeBSD installation. Ports will be that port selection that I was talking about earlier. If you want to contribute to the ports tree or add an application to FreeBSD, you'd probably want to include the ports. If you want to do FreeBSD development, you want to include the source tree. So this would just be in /user/source or /user/ports for ports, and you just have the ports and system tree there. There's also test suites and debugging utilities. I'm just going to go default. Like I said earlier, here, to use ZFS, I think we have more than 8 gigs. I hope so. Okay. So, like I said earlier, ZFS is implemented right into FreeBSD, and this is because ZFS has, I think, the CDDL license, which conflicted with the GNU GPL that Linux uses. So because of that, I don't believe that ZFS is allowed to be distributed with Linux. Ubuntu does, and I'm not sure what the logistics on that are, but for the longest time, Linux wasn't supposed to have it. FreeBSD has had ZFS for as long as I can remember. We're going to use ZFS. You're going to want to do stripe, and then, for example, pick your disk. Yes, we want to destroy it, and then it will go through, do the checksums, make sure that the ISO that you burned was correct, and then it will do the installation. So then, after this installation, you just reboot into your new FreeBSD system, and let's see how long this takes. The base is the biggest part, so let's see. But yeah, it's generally a really simple installation process. It's comparable to the Debian ncurses that you'd see when you're installing on a server. So here you enter your new password. I'm just going to do a simple password. And then you have a network interface. We're just going to skip network for now. We don't know. America. We want United States of America. Central. CST. Skip. And then right here you have your system configuration. You probably all know what SSH is. If you want SSH on your machine, click SSHD. We probably want NTPD. This keeps your system synced with the time, the local time. PowerD, if you have a laptop, this will enable power optimization. And then all the other stuff is pretty self-explanatory. Here you have a number of security options. Each do different things based on what they say. I'd specifically recommend disabling send mail just because it's annoying and it shouldn't even be in there. No one uses the send mail service anymore, and I like clearing temp. But all these, the rest of these are just security things, right? So I think Linux by default, most distributions, they randomize the PID. So when you create a new process, you'll get a random PID. Normally, if you don't do this, then you'll just get them sequentially. So if you spawn one, it will start with PID 455, and then the next one will be 456, 457. And the rest of these are pretty self-explanatory. We're not going to add any users, and then that's it. So then we can exit and reboot. And that will hopefully reboot the system. Usually, oh yeah, there we go. Okay, so then once this reboots here, I can take this USB flash drive out, and then if everything goes to plan, our military class motherboard will boot into our FreeBSD system. So again, we got the bootloader here. We can press enter, and then you'll get all the debugging stuff again. And normally it will try to search for networking, but we don't have networking. And then root. All right, and then what's really nice is when you log into FreeBSD, they'll give you a nice little introduction, say, hey, this is FreeBSD, look at all of our links, and of course you should look at all of those. But then you have your FreeBSD system, and this is just like what you'd see on your CSC lab machine. So you can do ls and cd into something. There's no directories, but CD. And yeah, just a generally Unix-like system. So let's shut that down, make the computer be quiet. But anyway, before I finish the talk, I wanted to give a big shout out to this book. This book is pretty much how I've learned everything about operating systems up until this point. It does an incredible guide, or it is an incredible guide if you want to learn more about operating systems. The lowest of the lowest level. It's made by Kirk McCusick and George Neville Neal. Kirk is one of the first BSD guys at Berkeley, so very smart guy. I read that book and I'm like, how the heck does this guy have so much information in his brain? But it's a great read, and I hope some of you got a good idea of what FreeBSD is out of this talk, and I appreciate you all coming. So thank you. If anyone has any questions, they can come up here and ask me. Otherwise, you can start leaving.